Okay, so this lesson will cover how you name, classify, and measure angles. First of all, what is an angle? An angle is two rays with the same endpoint. So for instance, here we have an angle that's made from ray AB and ray AC. And if I want to name that angle, then what I need to do is I need to take a point from the side, then the vertex, and then a point from the other side. So again, in the case of the angle I just highlighted in blue, I would call that angle BAC, or I could call it angle CAB. In either case, the vertex is the point that is in the center of the name. So there's a new word if you don't know what vertex is. Vertex is the point of the angle. And of course, this is a side over here and a side over here. So BAC or CAB. Now, since there's only one angle there, I could also call it angle A, and that would be okay because that's not ambiguous. I know exactly which angle I'm talking about. However, if I had a situation like these blue lines down here where I have multiple angles formed, I couldn't refer to, suppose I'm talking about this angle here that I'm highlighting in yellow. I could not call that angle H because I wouldn't know which angle you're talking about. I would have to call that either angle DHG, or I would have to call it angle GHD. Again, in either case, the vertex angle is the angle that's the point that is in the center of the name. Um, so I cannot call it angle H. That would not be okay. So we're going to draw a slash through that. Okay, that's ambiguous. Another thing you should know about angles is they have an interior and an exterior, and it's just like the word that we would use for anything else. The interior of the house is the inside of the house. Well, the interior of the angle is inside the angle, and the exterior of the angle would be outside of the angle. Okay, when it comes to classifying angles, there are 4 classifications that we use. An acute angle is an angle whose measure falls between 0 and 90 degrees. So it's either greater than 0 or less than 90 degrees. A right angle is exactly 90 degrees, so the measure of angle 2 here is equal to 90 degrees. And we designate a 90-degree angle by using this little square in the angle down there. That shows that that's a right angle. An obtuse angle, it's either it's between 90 and 180, so the measure of angle 3 here is greater than 90 or less than 180 degrees. And then finally, a straight angle is exactly 180 degrees, so the measure of angle A would be 180 degrees. Previously, we learned the segment addition postulate, the idea being that if I had a segment and I cut it into 2 pieces, the 2 pieces are going to add up to the whole thing. Well, the same is true with an angle. If I have an angle RST, so here's RST, that angle RST is going to be equal to the sum of the 2 pieces, the measure of RSP plus the measure of PST. So just like the segment addition postulate, the pieces add up to the whole. So for instance, if I told you that angle RSP was equal to 30 degrees, and I told you that angle PST was equal to 45 degrees, then I know the whole thing, RST, would have to be 75 degrees. On occasion, you're going to have problems where instead of giving you degrees, they're going to give you algebraic expressions to represent the angles. So in this example, we are given that the measure of FGJ is 155 degrees. So that means the whole angle altogether is 155 degrees. And we're going to find the measure of GFH and HFJ. Well, these two pieces, the 4x plus 4 added to the 4x minus 1, have to add up to the whole thing, 155. So I set up an equation. 4x plus 4 plus 4x minus 1 has to equal 155. Okay, and so we combine our like terms, 4x and 4x, I get 8x. 4 minus 1, I get 3. That has to equal 155. Subtract 3 from both sides, and I get that 8x is equal to 152. And then if you divide by 8, you get that x is equal to 19. Okay, here's where you have to be careful. Am I done with the problem? No, I'm not, because I'm supposed to be finding the measure of GFH and HFJ. So you always want to pay attention to what the instructions say and make sure you're answering the question that's asked. So I'm going to take that x equals 19, and I have to plug it in to those two expressions to find the measures of those angles. So first I'll go ahead and find the measure of angle GFH. That's equal to the 4x plus 4, so instead of x I'm going to write the 19. So 4 times 19 plus 4. 4 times 19 is 76. And so if I add 4 to that, I find that the measure of angle GFH is equal to 80 degrees. Then I can do the same thing for angle HFJ. It's equal to 4x minus 1, so 4 times 19 minus 1, which is 76 minus 1. And so the measure of angle HFJ would equal 75 degrees. And you can see if I take those two and add them together, 80 plus 75 does in fact add up to the 155 that we started with. Okay, if I have angles that are congruent, the way that we designate that in a picture is with arcs. So if angle 1 is congruent to angle 2, I make those little red arc marks in the angles. Now, when I'm talking about angle measures, the way that I write that is the measure of angle 1 is equal to the measure of angle 2. So when we're talking about measures, we use the equal sign, but if I'm talking about the actual angles, then I say that they are congruent. So I would say angle 1 is congruent to angle 2. And if you look at this other figure down here, when I have multiple angles that aren't all congruent to each other, then I need to use more than one arc. So in this picture here, you can see up here they have double arcs for angle L and M. So angle L is congruent to angle M in this figure, and angle P would be congruent to angle N. An angle bisector is a ray that divides an angle into two congruent angles. So in this figure, I have bisected angle ABC. So ray BD bisects angle ABC. So what that means then is that angle 1 is congruent to angle 2, because to bisect is to cut it in half exactly. So I could mark that in my picture, again with those little arcs, to show that those two are congruent to each other. So if, for instance, the measure of angle 1 was 29 degrees, then what would the measure of ABC be? Well, if the measure of angle 1 is 29 degrees, I know that the measure of angle 2 would also have to be 29 degrees. And so then I just add the 29 and the 29, and I have that the measure of angle ABC is equal to 58 degrees. Now in this second example, I'm going to use the same figure, but this time I'm told that the measure of angle 1 is equal to x plus 20. And the measure of angle 2 is 3x minus 4. So this one's going to be x plus 20, and angle 2 is 3x minus 4. And then I want to find the measure of angle ABC if that was the case. Well, I haven't told you what the whole thing is, but I have told you that angle 1 is congruent to angle 2 because it's a bisector. So that means that these two expressions, the x plus 20 and 3x minus 4, would have to equal each other in that case. So you would set them equal to each other. X plus 20 equals 3x minus 4. And you would solve for x. So if I subtract x from both sides and add the 4 to both sides, I get that 24 is equal to 2x, and so x would equal 12. Okay, but I'm not done. I want to know what the measure of angle ABC is. So I go and I plug that back in. The measure of angle 1 is 12 plus 20, 32. And the measure of angle 2 better come out to the same thing, but let's make sure by plugging it in. 3 times 12 is 36. 36 minus 4 is also 32. And so therefore the measure of angle ABC would be equal to 64 degrees. And then that would be your final answer. Okay, so suppose you have a figure where you're given a straight angle. KLM is a straight angle, and we know that a straight angle is equal to 180 degrees. And we're going to find the measure of KLN and NLM. So first of all, this whole thing is 180 degrees, and these two pieces are going to have to add up to 180 degrees. So I set up an equation, 10x minus 5 plus 4x plus 3. That has to equal 180. Combining like terms, I have 14x minus 2 is equal to 180. Then I add 2 to both sides. 14x is equal to 182. And then finally, dividing by 14, I get that x is equal to 13. So now I go back and I plug that in for angle KLN. It's going to be 10 times 13 minus 5, so that's 130 minus 5, or 125. So this angle here is 125 degrees. And then for the measure of angle NLM, I have 4 times 13 plus 3. So 4 times 13 is 52, plus 3, I get 55. And of course, you can always double check to make sure that 125 and 55 add up to 180, and in fact they do. Okay, need to add a little more information to this one here. This is going to be angle 1 here and angle 2 here. All right, so in this example now, I've given you the whole angle, XYZ is 72 degrees. And I'm still missing some information there. Angle 1 is equal to 2x minus 9. And angle 2 is 3x plus 6. So if I want to find the measure of angle 1 and angle 2, this time I can't make those equal to each other because I didn't say that YW bisects it. This is not a case where they're equal. This is one where you use the angle addition postulate. The two pieces are going to add up to the whole thing. So I take the two pieces, 2x minus 9 and 3x plus 6, add those together, they have to equal 72. Combining like terms, I get that 5x minus 3 is equal to 72. add 3 to both sides, 5x is equal to 75, and then dividing by 5, I get that x is equal to 15. So when I go back and plug that in, the measure of angle 1 is going to be 2 times 15 minus 9, so that's 30 minus 9, which is 21. And the measure of angle 2 is 3 times 15 plus 6. 3 times 15 is 45. 45 plus 6, and we get 51. And again, if you double check, it does in fact add up to 72, so you know you did it right. All right, the protractor postulate. The protractor postulate says that the measure of an angle is the absolute value of the difference between the numbers each angle side crosses on the protractor. So just like we can't have negative distance, the same is true with angle measures. Angle measures are always positive. So if I'm looking at angle WSR, I'm going from W to S to R. Well, it goes from 0 and it looks like it's going to 65. So 65 minus 0, of course, is still 65. So the measure of WSR would be 65 degrees. Next, I look at angle TSW. TSW in green there. And I can go from the 0 on the inside and look at the inside track, and it's going to go to 115. So that's 115 degrees. Angle RST is a straight angle, so that one's obvious. That's 180 degrees. And then angle VST is a right angle. It's 90 degrees. Okay, so we didn't have to do any subtraction on those. Suppose I look at this angle, WSV. The measure of angle WSV is going to be the difference between those 2 points. So it's going to be the absolute value of 90 minus 65. And so the measure of angle WSV would be 25. And that is all for now. Thank you for watching.